What we want to do is take a look at a control transformer now, and what this one is has multiple coils on it. It has a dual coil primary and a dual coil secondary. So the way that this can be set up is it can be set up as a 4-to-1 step up or step down, or it can be set up as a 2-to-1 step up or step down. Okay. So the first thing that we're going to do is we're going to take a look at the transformer. So I've got H1, H2, H3, H4, and then these are the connections on this side, 1, 2, 3, 4, and that's what's shown here. Except that these are showing the wiring of it, so you got to be careful when you look at this when it says H1, H2. Well, that is this. This is 1 and 2 in this case. That's the way that that would be marked. Okay, so just be sure that your designations here match up to the terminals on the transformer, or you're not going to get the readings that you want. So this has 8 pickup points, and it has 2 coils on this end and 2 coils on this end. So what I'm going to, first of all, what I'm going to do is I'm going to take a look at the coil, this first coil here between H1 and H2, okay? And so this is going to be a step-down transformer. So you would expect that we would have more windings on that end. So if I come to my multimeter and I set it to resistance right there, and I go ahead and I go across these two right here, I'm going to get my resistance of about 39.5. I'm just going to call this 39 ohms. So supposedly we got about 39 ohms. I'm then going to go ahead and check the one on this side over here, right here, and I'm going to see that on that one I've got about 17 ohms. I'm just rounding, okay? So I've got 39 ohms and I've got 17 ohms, okay? So this one, it's about, we're going to call it a little less than half, but we'll use half because this is supposed to be a 2-to-1 or a 4-to-1 transformer. So what does that mean? Well, because this one has more ohms, I'm guessing that this one has more turns, okay? So when we have more turns on this end, we're going to create a big magnetic field, but we don't have as many turns on this end. There's fewer. So there isn't as many turns to capture that magnetic field and turn it to voltage. So in this case, it seems like this would step the voltage down because this big magnetic field on this coil is not very big, so it's not going to capture very much of that magnetic field to create the voltage on this end. So we're going to go ahead and we're going to check it. So I'm going to come and I'm going to go and I'm going to set to AC voltage, and I'm going to take my voltage supply that we've been working with, and I'm just going to plug it into the first coil there. And then on this side, I'm still plugged into the second coil. I got it set to AC voltage, and I'm going to go ahead and check my source. So what are we doing up here on this source when I turn this on? So it looks like I've got about 27 volts. So on the top here, I would have 27 volts, okay, on this first coil. And what am I seeing on the second coil down here? Well, I'm going to take this and I'm going to just put it on this coil here. And I'm going to see, I'm going to turn this on, and I'm going to get about 16 volts. I'm shutting that off. Well, it's not a perfect world, and I'm rounding, so you would expect this to be 13 or 14 volts or something, but it's definitely stepping it down roughly 2-to-1, or roughly the ratio of these resistances. Now, there's some induction going on here. That's how this works. And the math doesn't exactly work out like that, but we're just approximating here the way that the way that Ohm's law would affect this, okay? But it's kind of stepping it down, all right? So if I wanted to step it down, that was a 2-to-1 step down right there. I just went from coil to coil. If I wanted to do a 4-to-1 on a step down, well, what I would have to do is I would have to make this coil even larger, right? And then I would keep a small coil over here to capture that magnetic field, but only a part of that magnetic field, okay? So in this case, what I'll do is I'll run a jumper between H2 and H3. So if I come up here, I unplug this, and I were to run a jumper across those two right there, I've now created 39 ohms, and these are jumper together, and 39 ohms. So you would think that between here and here, it would be about double that. So if I set this to ohms again, and I get my tester, and I bring it up on either side right here, I got about 79 ohms. So yeah, it looks like it kind of doubled the ohms across there, right? And so now I've got quite a few turns, a lot of turns here. And then I've got, since I'm only doing this one coil, I've only got a few turns. I probably got about 4 times as many turns up here than I do there. So hopefully we would get about a 4 to 1. So once again, I'm going to go ahead and put my voltage right here. Okay. And I'm going to turn this on. I'll set this to AC voltage. And when I check this, I should once again have about, I think we're about 27 volts or something like that. Looks like 26.6, yep. And then if I were to come here just to this single coil right here, okay, I would see that I have about 8 volts. So the second time, what we did is we came here and we hooked 1, 2, and then we had just the small one here again, so we got 27 volts. And here we're getting about 8 volts. Well, it's supposed to be 4 to 1, so you would think half of 27 is about 14, half of 14 would be about 7 or less than 7. So 13 and a half, 6 and 3/4, but we're close. So this is stepping it down. It's supposed to be stepping it down to about 4 to 1. Okay, so in a industrial control transformer, excuse me, you would hook these coils up so that you are using all of the coils here so that you can correctly and efficiently transfer the power. Okay, and be sure that power is produced on this end by the current, and then power is produced on this end by the magnetism. Okay, so I'm going to go ahead and I'm going to shut this off. So normally, when you see a control transformer, you can put these in series, and that's like we did, or you would do parallel. So if you have 2 coils in parallel, well, that would look something like this, where you would have 27 volts, and you would have 1 coil, and you would have 2 coils, right? And so the first coil right here was H1 and H2. That was the first coil, because H1 goes to H2, and the next coil here was H3, and that went to H4. Okay, and so what these do is they don't, because the voltage is the same, 27 across each one of these. All this does is it doesn't create more of a magnetic field. Putting them in series, that's definitely increased my turns and affected my voltage. This makes it parallel. It just makes this magnetic field and this magnetic field kind of work the same as it's applied to the 27 volts. And so what do I mean by that? So let's go ahead and hook this up. Okay, so I'm going to unhook this. Okay, and according to this, I need to have power going to H1 and power going to H2. So if I take this and I will have the power going to H1 and H2, it kind of works like that. Okay, and then I would need H1 going to H3 like this. Okay, and I would have H2 going to H4, and that would be kind of like this. Okay, the wiring scheme that you would normally see, because this wire and this wire, these are all the same contact point like that, you're typically going to see it jumpered like this, and then the power's on the outside. Okay, you'd have the power's on the outside, and then the jumper's on the inside like this. And basically then what we've done is we've created this parallel here to just deliver power properly using the 2 coils in parallel. Okay, and then so if I went ahead and switched this on again, I'm still set up here to measure voltage on the secondary. When I click this on, I'm getting 16 volts there. Okay, so this parallel gave me my 16 here, and so that was what we had the first time. I'm still only using one coil, and the step down was about 2 to 1 right there, okay? The way that this transformer works is I would also want to use both of the coils on this one for this to work correctly. And so, like I said, you would pick off the two sides. So I came here and I picked out the two sides. And then we would have to jumper just like we did up here, the two in parallel. So this one would get jumped in parallel to that one. And then the outside here, X2, gets parallel to there. Okay? And then so when I go ahead and click my power on, I'm going to get 16 volts, which is close to my 2 to 1 step down. This should be a 2 to 1, and then that is what we created right there. The um, the typical control transformer might only have one coil on this side, so you might still have these two coils that you would either wire in series with a jumper right there like that, or if you were going to wire them in parallel, what we did is we ran a jumper from H1 to H3 and from H2 to H4. And these were our lines right here. This is where we ran line 1 in and line 2 out. And you might not see this second coil. You might only see a single fixed coil on this side, okay? This transformer, because it has two coils, just gives you a little more flexibility. And then that's for parallel, that's 2 to 1 step down. If you wanted a 4 to 1 step down, you would connect right here, because then you've made double the amount of coils, still with a fixed coil here, and your resistance, like we said, was about a fourth. So that is some transformer concepts of how the coils on the primary side can be put in series or parallel in order to get a 4 to 1 or a 2 to 1 step down.